Okay, so today we are going to cover Chapter 4, Section 2, and today we're going to learn how to graph rational functions. Now, we will take a quiz on graphing rational functions. You will be able to use your graphing calculators. So it's going to be important that you understand how to use your graphing calculator in order to help you on the quiz next week. I know yesterday I said there would not be a quiz next week, but we will take a calculator quiz just on sections 4.1 and 4.2. And essentially it's really 4.2. You're just using the knowledge from 4.1 of finding asymptotes. So the steps that we're going to follow is to first thing we're going to do is find the asymptote, the horizontal asymptote, by looking at the degree. Then from there, we would simplify our expression and use the simplified denominator to find your vertical asymptote. And then any factor that you simplified, that's where we'll locate a hole. And then we'll find the zeros. And the zeros are the X-intercepts. So we would plug in y equals 0 to find an X-intercept. To find the y-intercept, to find X-intercepts, we're going to set y equal to 0. And to find the y-intercepts, we set x equal to 0. And then we would simplify. And then we're going to find additional points. And then we'll graph our rational functions. Now, we'll be able to use our calculators to get the additional points. Now, I will do the first example showing you what you would have to do if you weren't using a graphing calculator to get your additional points. So let's go through and I'll take it step by step. So this is my first rational function. The first thing I'm going to do is look to see I can't simplify it. So let me go ahead and next would be to find my asymptotes. Nothing simplifies, so nothing canceled out. So this graph does not have any holes. So remember, for the horizontal asymptote, we are going to look at the degrees. The constant, the numerator, has a degree of 0. The denominator has a degree of 1. When the top or the numerator is smaller, we automatically know by default our horizontal asymptote is at y equals 0. For the vertical asymptote, we're going to set the denominator equal to 0. So x minus 2 equals 0. And my vertical asymptote is located at x equals 2. Now I need to find my zeros, my x-intercepts. So now to find the x-intercepts, I'm setting y equal to 0. And again, remember the function notation that g of x is really y. So what I'm going to do is get 0 equals, and I'm going to plug in the original function 3 over x minus 2. And now what I need to do here is solve. I need to get this expression that's in the bottom out of the bottom. This cancels. Anything times 0 is 0. There was no variable in the numerator, so this is nonsense. So this means that there are no x-intercepts. Bottom line, all we need to do is set the numerator equal to 0 to find x-intercepts. Okay, so the shortcut is just setting the numerator equal to 0 to find your x-intercepts. Because again, you're plugging in 0, and when you try to get that denominator out and to the other side, you're timesing it by 0, which makes it disappear. Now, for the y-intercept, we are going to set x equal to 0. So again, I'm taking the original function, I know it said g of x, but I'm going to put y equals, and then it was 3 over 0 minus 2. And then once I do 0 minus 2, I get negative 2 in the denominator. So my y-intercept is going to be the order pair 0, because that's what I plugged in for x, negative 3 over 2. Now, we're graphing this, so this is actually negative 1.5. Now, I'm going to go ahead and get my asymptotes on the graph and my y-intercept. There was no x-intercept. Let me get those on there. And then from there, I can see where I need to look for additional points. So let me go ahead and graph the horizontal asymptote first. I'll graph that in red because that's what I did the work on. So here is my horizontal asymptote. It's actually the x-axis. Then my vertical asymptote is that vertical line through x equals 2. So if I zoom in here at 2, let me do it in highlight. So I have a vertical asymptote going through x equals 2. Now, this is going to be the boundaries lines where my graph is going to have to stop. Now, I don't know if my graph is going to be here, 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 or here. This is where plugging in or graphing the intercepts and graphing the additional points is going to help me. So I already have my y-intercept, so I can go ahead and graph that. And that's this order pair 0, negative 3 over 2. So right here, this is my y-intercept. So this already tells me that my graph, and again, the graphs of these rational functions are going to look like boomerangs or like hyperbolas. So I already know I'm going to have something here, and now I just have to figure out where the other one is. And it's going to be up here. But in order to determine that, I can key this into my graphing utility to get additional points. But if you weren't using a graphing calculator, you would do a table of values. So you would do an x column for the x's you plug in, and then I would put the function here. And what I need to do is I'm going to pick numbers that are to the left of my vertical asymptote and to the right of my vertical asymptote. And you can choose whatever x's you want. So I'm actually going to plug in numbers for the left of the blue line, negative 1 and positive 1. So 3 over negative 1 minus 2 gives me 3 over negative 3, which gives me negative 1. So the order pair I can graph is negative 1, negative 1. Let me plug in a positive 1 to get another point over there to the left of the blue line. So 3 over 1 minus 2. 3 over negative 1, which is negative 3, so positive 1, negative 3. So let me go ahead and graph these two. So right here, and then 1, 2, 3. So here is this part of the graph, and it skims along both the horizontal asymptote, which is red, and the vertical, which is the blue. Now I need to find the other piece of the graph. So let me plug in x values that are to the to the right of the blue line. So let me plug in, I could pick any number that's bigger than 2. I could pick fractions, but I'm going to plug in 3, and I'm also going to plug in 5. So 3 over 3 minus 2. 3 minus 2 is 1. So then I'm going to graph the order pair 3, 3. And then when I plug in 5, I get 3 over 3, which gives me 1, so 5 comma 1. So let me graph these two order pairs to get my other little boomerang piece or my other piece of the graph. So I'm going to graph 3, 3 and 5, 1. And again, connect it. Use the asymptotes as your guide. Now, this would have been the process if we were not using a graphing utility. You still have to do all the work for getting those asymptotes. Now, let me show you how you can use your graphing utility to get the ordered pairs instead of having to do a table. Now, what's going to be very important is that when you enter your equation into the y equals, you use parentheses around the numerator and parentheses around the denominator. So for example, when you key it into your calculator, if you have the TI, you're going to hit the y equals button. And then when you do that, you're going to key in, put a 3 in a parentheses, then divided by x minus 2. Now, you can also use that math button and key it in as a fraction if you want. But if you're not going to use the fraction, put parentheses around the numerator and the denominator. So when I key this in, and I'll show you with my calculator or my camera. Let me see, what time are we here till 10:10. I'm going to skip over example 2 because it's the same. I'm going to jump to example 3 because it's got 3 examples, but I'm going to do example 2 in the video. So jump over 2 for right now. Okay, so let's go ahead and I'll complete example 2. So again, nothing can be simplified here, so there will not be any holes in this graph. So let's go ahead and find the asymptotes. So for the horizontal asymptote, remember we're going to look at the degrees. The degree of the numerator is 1. The degree of the denominator is 1. So when the degrees are the same, we're going to use the coefficients. So the coefficients that I'm going to be using is this 2 that's in front of x. And then again, we can assume that there's a 1 in front of this x. So my horizontal asymptote is going to be y equals 2 over 1, or just y equals 2. For the vertical asymptote, we're going to set the denominator equal to 0. So it's just an x equals 0. To find my intercepts, I can find my x-intercept first by setting y equal to 0. And again, you could take your function, plug in a 0 for y. Again, essentially all we're really doing here is setting the numerator equal to 0, because watch what happens when I try to get rid of the denominator. Once I multiply both sides by an x to get x out of the denominator, it cancels on the right side, but then 0 times anything is just 0. And then I'm left with 2x minus 1. So essentially, when you're finding the x-intercept, all you need to do is set the numerator equal to 0. So now I'm left with 2x equals 1, divide by 2, x equals 1/2. So my y-intercept is going to be the ordered pair. I'm sorry, my x-intercept is going to be 1/2, comma 0. For my y-intercept, we're going to set x equal to 0. So y-intercept, set x equal to 0. So again, use the original function. So y equals 2x minus 1 over x. So in here, I'm going to replace all the x's with a 0. And now for here, I end up with negative 1 over 0. And I can't have a 0 on the bottom, so this is undefined. So there is no y-intercept on this function. So let's go ahead and put some of this information into our coordinate plane here. So I'll graph my horizontal asymptote. So it's the equation y equals 2. So I can go ahead and graph my horizontal line that's going through positive 2. Then I can graph my vertical asymptote, which is actually the y-axis, it's x equals 0, I can now graph my x-intercept, and as it's at 1/2, 0, so I could put it right there. And then again, there was no y-intercept. So I can already see that my graph is going to come and be in this section, and it would skim along the asymptote. But let me go ahead, and when you're taking the quiz on this, you're going to use your graphing utility to get additional points. But let's say you were taking a test on this, or say an SAT, and you couldn't use a graphing calculator, then you would have to have done a table of values. So just to demonstrate, I would need to pick x values that are to the left of the blue line and to the right. So I could actually plug in -1 and +1 into my function just to get an additional order pair. So the function I'm plugging it into is the original 2x minus 1 over x. So I'm going to do 2 times -1 minus 1 over -1, which gives me -2 minus 1 over -1, which gives me -3 over -1, which is +3. So the order pair here, when you plug in -1, is -1, +3. Then I'm going to do the same thing and plug in +1 into the function. Again, there's no set number you need to plug in. You can choose this. So 2 minus 1 over 1, 1 over 1. So then the order pair, when you plugged in an x value of 1, is 1, 1. And again, you're using your graphing calculator to get order pairs, so you don't need to do this table. So you would just click the y equals button, type in your function. Remember, when you type it in, you need to put parentheses around the numerator. So you would hit the y equals button if you have the TI 83 or 84. You would put parentheses around the numerator, divided by parentheses around the denominator. And then you can hit the graph button to see what the graph looks like, or you can hit second and then the graph button, and then that will give you the table or the list of all the order pairs. So again, graphing this, I can see -1, +3. So my graph is up here, and then also the other order pair, the 1, 1, was right here. So again, I can see the two locations for my graph. And again, you're using the asymptotes as the guide. So that would be the graph of that rational function. So again, when you're doing the homework, you're going to show all the work that you used in order to find the horizontal asymptote, the vertical, the intercepts, and then again, from your calculator, you can just list some order pairs that you would have graphed. Now, also in the homework, it also asks you to list the domain. So the domain in words is going to be all real numbers except x equals 0. That's where our asymptote is located. In interval notation, it would be from -infinity to 0. And notice these are parentheses around the 0 because it does not include 0. So this would be an example of this rational function graphed. Let me get to number 3 because it is a shortened class. So again, for the horizontal asymptote, remember we need to look at the degrees. So the degree of the top is a 1. The degree of the bottom is 2. So again, the top is smaller. So my horizontal asymptote is the same. It's y equals 0. For the vertical asymptote, what we're doing is setting the denominator equal to 0. So x squared minus x minus 2. Nothing can be simplified here. So I need to factor that denominator, it factors into x minus 2 and x plus 1. So this one is going to have 2 vertical asymptotes. So x minus 2 equals 0, x plus 1 equals 0. I'm going to add 2. I have 1 vertical asymptote located at x equals 2, and then another one at negative 1. So let me go ahead and just put these on the graph right now. Here's my horizontal. It's in red. And then I have 2 vertical ones. One at x equals 2, and I'm going to do those in blue. And then another one at x equals negative 1. Okay, so then the next thing I'm going to do is find my x and my y intercepts. Notice nothing's simplified here, so this one doesn't have holes either. So for my x-intercept, I set y equal to 0. And again, remember, setting y equal to 0 is just this. Again, all you're really doing is setting the numerator equal to 0, because once I try to solve this by moving this out of the bottom and multiplying anything by 0, this just cancels and becomes 0 equals x. So my x-intercept is the order pair 0, 0. My y-intercept, I'm setting x equal to 0. So y equals 0 over 0 squared minus 0 minus 2. 0 over negative 2, 0 divided by anything is just 0. So my y-intercept is also 0, 0. So I can put that point on there. Now, the only asymptote that your graph will sometimes cross is the horizontal. It will never cross a vertical. Now, I've got 3 separate sections that those blue lines have created. Now, when you make the graphs to the left and the right of the asymptote, it's like a boomerang. But when you have a section in between 2 blue lines, this section right here is either, depending on the equation, is either going to take on the shape of an x cubed graph or a negative x cubed graph. In this particular problem, we're going to see that it's the negative x cubed graph. Now again, I don't need to do the whole table of values for this. I'm going to key this in my graphing calculator now to get the points for my graph. So if I key it in, and again, when you key it in, you need to key it in as the y equals button, do a parenthesis around the x, then divide it by x squared minus x minus 2. If you're using the division and not entering it as a fraction. So let me go ahead and key this in. Clear it. And then I'll show you what it looks like. And again, I'm putting it in parentheses. All right, let me show you what. Get the additional order pairs from our calculator. Some order pairs that would have been good from the graph. I saw that -2, -0.5. And then I could also grab 1 and -0.5 as well. And then 3 and 3/4. Notice a lot of them were fractions. So again, let me go ahead and put some of these on my graph. So the -2 and the -0.5 would have been right here. And again, we already know it's located there, and we saw it from our graph, and it needs like a little bend here. Make it a little curve shape. And then over here, the same thing with the 1, 2, 3, and the 3/4. And again, we already see it from our graph. I'm not looking for precision, just where it's located. And then over here, I also had the order pair +1, -0.5, which was here. And this told me it was taking on the shape of the negative x cubed graph. So again, you don't need to do the whole table when you're using your graphing utilities. Just get these additional points from your calculator. And then connect the points, add arrows to the end, and show how it's moving. Let me see if I can do one more with a hole in it. That would be example 4. And I did, here is example 3. And again, I graphed it. Notice there were 3 separations because we had 2 vertical asymptotes. And again, these additional points came from the calculator. So again, for the degrees here, for the horizontal, you can see that the degrees are the same. It's 2 over 2. So this tells me I would use the coefficients. The coefficients are a 1 and a 1. So 1 over 1, my horizontal asymptote is just y equals 1. My vertical asymptote, I need to use the denominator. So I need to use the simplified denominator. So let me go ahead and simplify this or factor it first. So x squared minus 9 factors into x plus 3, x minus 3. The denominator will factor into x plus 1, x minus 3. Notice the x minus 3's cancel. This is where my hole is going to be located. But my vertical asymptote, I'm setting the denominator equal to 0. So I have a vertical asymptote located at x equals -1. So I could graph my horizontal. I've got it here at y equals 1. Let me do it in red. I've got my vertical at x equals -1. I'm now going to find the location of the hole. I'm going to take x minus 3, set it equal to 0. I'm now going to take that 3 and plug it in to the simplified function. And it was x plus 3 over x plus 1. So 3 plus 3, 3 plus 1, and remember g of x is just y. So 6 over 4, 3 over 2. So my hole is located at 3 comma 3 over 2, which is really 1.5. So what I'm going to do is I'm going to come over to my graph and put an open circle here. And then from there, I can go ahead and find my x-intercepts, my y-intercepts, and then get the additional order pairs. So again, to find an x-intercept, we're setting y equal to 0. Again, really all I need to do is set the numerator equal to 0. So I'm just going to do x plus 3 equals 0. So my x-intercept is located at -3 comma 0. My y-intercept, I'm setting x equal to 0. So when I plug it into the simplified, I get 0 plus 3 over 0 plus 1. And then this gives me 3 over 1. So my y-intercept is going to be the order pair 0 comma 3. So let me go ahead and put these points on my graph. And then the -3 comma 0. And now you can already see it. Your boomerang or your hyperbola type shape is going to be going right here, skimming along these asymptotes. And then same thing here. But it doesn't go through the hole. So it comes up to it, and then it jumps over the hole, and it keeps going. But again, we would go and key this into our graphing calculator. You can key in the original. Some additional order pairs could have been the order pair -2, -1, and then +1, +2. So you're going to write down on the quiz, you're going to tell me the additional points that you got from your calculator. So again, I want to still see all this work. I want to see the work for the asymptotes, see the work for the intercepts, see the work for the holes, and then I want to see, you could just list the additional points from your calculator. And then example 4 had the hole in it. And then what I'll end up doing is I will make a second video working out 5, 6, and 7.